Okay, so myself, Leena. I'm from India, Bangalore, India, and I've been hearing about pipeline for quite some time. This time, I thought, okay, let me try as a speaker, and that's the reason I'm here. Glad to be here. Way to start the conference with Dan North's talk. I hope I'll be able to share some more experiences and then some more things into the continuous delivery way through my talk. And before I start, just a quick poll to get a sense of what kind of audience I have so that I can render the rest of the talk accordingly. Just want to know how many are consider themselves as like already doing continuous delivery for some time, has been doing it for some time. This, okay, okay, who are about to start or on the plans of starting, want to do it, okay, and know about it, but I may do it later or it may not for me, that kind of range. Okay, so so I would say my talk will be just the beginning. How do you get started with continuous delivery? I would say this is the beginning. That is the reason I kept it as a beginner talk. So rather than a lot of lecture, I try to integrate a lot of stories, some actual stories, some my experiences converted into some kind of a, I hope it is a joke, but I hope you all will laugh at my joke. Otherwise, it's a feedback for me, quick feedback that no one is enjoying those jokes anymore. So this is Bob. He's an entrepreneur. He has a fantastic product idea. He's all thrilled with that idea. And because he knows that it's a cool $1 million company that he's going to build it. And he creates a lot of business plans around it, the growth plan, ROIs, all that's he set. And he's very excited to start. And he hires Team X for building the product. Team X consists of a lot of fantastic programmers, designers, all kinds of roles that you expect to do a product delivery or a product development of a product. They're very, very talented, no questions about that. All are excited to start on the product. They're very, very excited and they're very happy. You can look at them. And what happens after some time, this is what happens after a few months or say a little bit about few weeks. They start fighting. They were excited, but that excitement is no more existing. So what happened was they went in silos into build, and then they started building their own stuff, and then they started integrating their stuff. This is what happens. And they start fighting, and the usual thing, that is a bug starts cropping up. Bugs mainly of two types. That is when they integrated, so it starts breaking something else. That is one set of problems. When Bob, the founder, when he started looking at the application, what he visualized and what got built was entirely different. And that's also the standard thing that developers say, it's okay, it's not a bug, it's a feature, and that kind of a fight that goes on. So not at all a good kind of an environment, and the motivated team starts trying to run away. They wanted to finally release it somehow, and they made it in the end, but when they released it, that is another problem that happened. There are hardly any users for the product. Okay, and the old fight they had, the frustration they had, that became further when they went into market. And so I think some version of this is all of us are familiar with, not the exact same version. Some of it, all of us are either all of us have faced, or especially those who moved into continuous delivery might have faced this, and that's the reason they moved into that. Or you might have seen it with other teams, or you would have read it in multiple places. And what is actually going wrong? That is one is a major last mile problem. That's the classic quote. That is 90% of the work takes 90% of the time, and the last 10% takes another 90% of the time. So that is what happened to Team X and Bob. And so in my opinion, there are two problems in the entire thing. What is that? One is that they built something no one wants. And this is not at all a good situation to be in. And that is where lean startup comes into picture, popularized by Rick Ries. So I'm not going to concentrate on that. But if you want to do So all lean startup is in the premise of experiments. Okay, just try this and see how users react to this, how they use it, what kind of changes they are ready to make in their own workflow after using this. So those kind of things, experimentation is the key thing behind lean startup. And for us to do create that kind of an environment, you need good technical support for that, engineering support for that, and that is where continuous delivery comes into picture. And the other problem that you usually see in the last mile is this classic quote by Mary and Poppendick in the book Agile Software Development, that is the lean software development and agile toolkit. In that, okay, how much time does it take for a one line change? One line means it can be just a color change for a button that you have. How long it takes? Does it take minutes or hours or months? And that tells the maturity of the kind of value stream that Dan mentioned in the keynote. How much time it takes. So that is a value stream, and how can you make it better and better and better? And that is the premise behind continuous delivery. That is, make sure that the code is always releasable. Whether to release it or not is another question, but that doesn't matter. But anytime when a commit goes in, it has to be completely confident that, okay, it is ready to release. And for it to get right, we need a deployment pipeline. So just to emphasize, I'm not talking about tools behind this. This is the thought process. Okay, how does the code travel from the developer machine until the production? That is what is build pipeline is all about, or the deployment pipeline is all about. And it kicks in when someone commits anything to the repository, and then depending upon what kind of product you are building in, the stages in pipeline can vary. But this is a minimum that you can see in almost all software products. You have to build it, you have to test it, and then deploy it. Whether you need a staging server, then there will be another stage for that. If you have a different testing setup, you will have a stage for that in the deployment pipeline. That steps can vary, but how does it travel, right? And it can also be, some cases it can be automated. The moment you commit, it can run the automated test to tell you, okay, whether it has broken something else, or is it things as was working yesterday, is it still working? And others can be manual, stuff like when to deploy to certain environment, especially the production. That depends on the kind of context that you are in, kind of product that you are building in. And the key for this is continuous integration. The first step to build a deployment pipeline is to have a correct continuous integration setup. And what I've seen is that the definition of continuous integration is misunderstood. It is called continuous integration if the entire team is committing to a single branch. Okay, this is the definition from Wikipedia. If you are having multiple branches and the team is checking into that branch, and if you're doing continuous integration against different branches, it's not continuous integration, because you are not getting the feedback, the changes that you have made. Unless you merge those branches together, you will not know whether it is still going to work fine or not. So the key thing for continuous integration is to have mainline development. That is the entire team committing to the same branch, which is called the trunk or the mainline or the master. And anytime there is a commit to that, the build kicks in and tells you, okay, whether it is working fine or not. And that is what the correct integration. That's the correct implementation of a continuous integration. And but then the question arises, what happens to features which are taking longer? What happens to features which require certain acceptance from stakeholders, or when you have certain testing to be done, so security compliance or some other compliance that you have to implement, or you want to do a performance testing, only after that you want to move to production. What happens in those kind of situations? That is where feature toggles comes into picture. Many people call this with different terms, like some say it is feature flips, feature switches. So there are a lot of terminologies exist throughout this talk. I'll be referring it as toggles, feature toggles. That is, it is a small setup usually in your configuration to turn on or off features depending upon certain condition. That condition can be, so this is a Ruby code, so I just pasted it. There is nothing much to understand. If certain condition is true, do something, otherwise do something else. And this is what feature toggle does. And it is usually triggered through configuration files, and then it can be you want to turn it on certain environments, and you have to turn it off in production because of until certain things are done, or it can be depending on you want to open it for a few users. Okay, and we'll see different kinds of toggles like that in the rest of the talk. Like I mentioned, it is through configuration files. And there are actually 3 types of toggles. This is the most commonly used toggles, which is called release toggles. The idea is that you segregate deploys and releases. You can continually deploy without releasing. Because you can turn off feature at the production at your will, and also but you can still continue to deploy. You don't have to maintain different branches because you want to release certain things only after a certain time. Okay. One more advantage with this is that you can quickly roll back things. Say you released a feature and then you started noticing some kind of a misbehavior in production, and then you want to turn it off. It is just another turning off the feature toggle in your configuration and deploying it again. It is as simple as that. You don't have to revert the entire code, and you don't have to deploy another branch. Okay, and this is the most common things usually used in for through feature toggles. The next one is called experiment toggles. This is for quick testing, quick experimentation, and I think most of you might have heard this term called A/B testing. That is testing multiple versions of the app, or multiple versions of the same page, or a part of a same page with different implementation, and release it to different user base and see how it improves the conversion, which is improving the conversion and which is not. And from that experiment you learn and then implement the actual implementation. It can be it can be a tester version, or what you can do is that looking at the data you can say, okay, certain things in certain version were better. You combine another version and release it again. And so this as the name suggests, it is for experiments. Okay, what works for the user, what kind of things people are emotional usability. That is what Danout mentioned. Okay, which creates better emotions with the user. You can see that when the conversion improves. Another kind of experimentation is through canary testing. That is, it was very popularized by Facebooks and Googles. That is, they usually release the feature to a certain set of users and then see how they react to that, and then increase the user base. So this is for gradual rollout. Two advantages that you get with this is, one is that you can get somewhat similar to the A/B testing. You can see, okay, how users are reacting to your new implementation. And the next one is feedback about your design and architecture. How does it well support the architecture? In case gradually when you are releasing it, does it system is still able to handle that load? If there is a problem, you can just reduce the user base and then release it again. So this is also for testing. And so rather than releasing it to the entire user base and then bombing the system, you can do a gradual release of it through canary releasing. And the last one is called ops toggles. I've not heard a lot about this. So there's a fantastic article in Martin Fowler's Blicky about the entire types of feature toggles. So I'll be sharing the links to all the things that I'm referring as part of the slides, and I'll be sharing it into it after the talk. So ops toggles is usually feature toggles are short-lived. You create it until a certain time is done, and then you delete the feature toggle because with feature toggle you are adding the complexity to the code by if-else. And if you keep lot of toggles, then it's a problem. So you should delete the feature toggle after a certain time, except for ops toggles. So ops toggles are for controlling certain kinds of highly resource intensive kind of a feature, or say where you are depending on a third party configuration or third party APIs like that. So for example, you have in your application you have a part where you are relying on a third party API. say there is a problem at the third party end, either it is down or their response time is taking a lot of time, and it is indeed going to affect your application, its performance. So in those kinds of situations, to implement the circuit breakers, you can use ops toggles. Say if the API doesn't respond within this time, then you can show a cached version of that, or you can completely turn off that feature. You build this either as an intelligence within the application, or when you start seeing the response time taking longer, you can turn off this feature and deploy it again, and then inform the user that this is down because of this reason. So it is a degraded experience for the user, but much better than actually bringing down the entire system down. Okay, so this is a very cool way to actually control when you have a lot of dependencies which are not in your control, and you can keep this for longer, so as long as you are dependent on that third party services. And so we spoke about different kinds of toggles to turn off or turn on feature depending on a certain condition. What about big architecture rewrites or big architecture changes or design changes that you are adding to the system? How can you continuously deliver that? The whole idea of feature toggle is to make sure that every commit can go to production without breaking the system. And how can you do that even for major architectural changes or major design changes within our application? And that there are patterns for that too. One popular pattern is called branch by abstraction. So I'll share an experience that I had with branch by abstraction. So we were building a product for, so I come from a consulting background. I'm heading the engineering team of a consulting firm in Bangalore. I'm also the co-founder of that same company. And so we were building a product for one of our customers, which was designing. You can custom design your t-shirts using that software, and so users can come into the site, add whatever content they want to print on your t-shirt or any other goodies that you choose to, and so they can upload their own images, they can upload logos, they can add message, they can define the text size, the rotation, so on and so forth. Whatever you expect to in a t-shirt design, you can do it online. And so we were using a certain library for converting that what they see on the screen. Finally, it has to be printed to a PDF so that we can give it to the vendors for printing on the t-shirt. So what was happening was the library we were using to get the right coordinates, the right angle, everything has to be similar what they've seen on the UI. The spacing between the content, everything has to be the same. And we were using a certain library, and after a certain time, we for implementing a certain feature, we realized that library doesn't support it well, or it is not the most optimal way of implementing it. And we wanted to move to another implementation. And we didn't want to go into a shell, rewrite the entire thing and release it again. We wanted to do it in a continuous delivery fashion. And so what we did was we introduced an abstraction layer. And that right now talks to first it will talk to the existing implementation. And then over a period of time, we gradually removed that abstraction layer to the new layer. So so for a certain time, we had both libraries in production. For certain kinds of features, it will use the earlier library. For certain kinds of features, it will use the current library. So we were also getting the feedback that okay, the current library works in certain conditions. We tested the most riskiest path first, so that we are sure that okay, the library choice is correct. So those kind of implementation you can do with branch by abstraction. Yes, you have to create an extra layer, but if you're following a right abstraction patterns, you will anyway do that. You will have a layer to talk to the third-party services rather than having the code distributor all over to talk to the third-party services or third-party libraries like that. So this is about abstraction layer, and then you can continuously deliver your changes to major changes to your libraries or so using this kind of a technique. And next thing is about Strangler pattern. This is popularized by microservices. You have a big monolithic application. How do you convert it into smaller application or convert it into, say, it was using SOAP and you want to move everything into REST-based application, how can you do that? So branch by abstraction introduces a abstraction layer. Here it introduces a route. At the router level, it introduces an abstraction saying, okay, where do you want to route the codes to? So as you are building newer and newer applications, which is implementing the same thing that is existing in the monolithic, the router routes to the newer ones. And over a period of time, you can get rid of the old application and completely use the newer one. And this also gives you an opportunity to rewrite those which are used by the users. You don't have to just copy the entire application, because only you know the 80-20 rule. Only 20% of the features are being used by the 80% of the users. And then, so those kind of opportunities you can get. Even without bringing down the service for a minute, you can do this. So this is the way to take major rewriting or refactoring of your applications, which still can be done. I included this in the feature toggles because this is also following the same mindset. How can we continuously deliver it? So it's not strictly part of feature toggles, but it's still added because it's very, very relevant. Because every time when you're making a change, any change to the application, you have to think about how can you continuously deliver it. And then that is the reason why I brought this up. Now the last side, every implementation or every pattern has pros and cons. There is nothing like a perfect solution, right? It doesn't work in that way. And feature toggles also has cons. It is not that it gives you a lot of advantages, but it gives you disadvantages. One is that it introduces an if-else. Which is a complexity from the cyclomatic complexity point of view, which is against that. You are not supposed to. You should be avoiding if else as much as possible, but we have to do that for feature toggles because of the advantages gives in. It's worth it. So this is an actual case that happened in one of our projects. We had these many toggles created in that application when we checked after some time. And that too, we started noticing it when the tool that we are using for cyclomatic complexity started complaining that, okay, you have a lot of if-else in your code. And so when we analyzed it, we realized that, okay, many of them are not required. Usually, feature toggles, like I mentioned, it has to be short-lived. It has to be deleted after some time. But to bring into that kind of a discipline, it takes a lot of time. And so this is what happened when we were not deleting at the right time. And so the question is, okay, what is the solution to it? And it's a dollar question. So there is no one rule. Okay, if you do this, this is how you can achieve it. I would like to relate it to technical debt. That is, how do you avoid that, or how do you avoid bugs? Right? The only answer is like, don't create that, don't write bugs, right? But it doesn't happen. We all know that. It comes, right? And similarly, how do you completely avoid this kind of a situation? There is no golden answer for that. But there is one technique though, which worked to an extent for us, but it takes a while to get there. The idea is expiry date. That is, when you create as a team, when you create a feature toggle, say that, okay, this has to be expired by this time. Either create reminders within your system, or create, if you are using Kanban board or any other planning tool, add a card which is due on a certain date to delete it. Over a period of time, I think people start noticing that, bring it up in your stand-ups if you are following that, or add automatic reminders to, okay, whichever way works it for you. After some time, you can see that it kicks in within the team. Over a period of time, like how TDD works, right? I mean, initially it is very, very difficult for you to write the test first and make it fail and then add the code later. Those who know, who are following TDD, or who tries to follow TDD, you find it very, very counterintuitive. But after some time, it becomes a practice for them, right? Similarly, over here also, after some time, people know that, okay, I have to delete it, and this is time to delete that particular thing. And then team also kicks in when they start seeing other toggles which are not being used. They will delete it by themselves. You don't have to wait for someone to tell them, okay, you have to delete this particular toggle. And I've read somewhere that one team has gone further step ahead, that they have automated the entire thing. So what they did was they look at for expired feature toggles, and then what they say is that what they do in the build pipeline is that if there are any toggles that exist beyond this time, it breaks the build. The build will be failing. In that way, it is a complete automated system, and then people start noticing that. If they are really following continuous integration, they really listen to those kind of failures and then fix it. So I've not tried that, but expiry date as a concept has really worked for us as a team. And just to emphasize, I hope, how many of you are familiar with this pattern, cathedral versus bazaar? This is coming from the Linux model, when Linux made open source, and it's more like a bazaar model. Anyone can come in and commit the code. What I would like to say is that, what I'm trying to say is that, in case of a bazaar model where it is an open source kind of a world, the pull model or the branching makes really sense, because you need a complete control, little bit more controlled environment to make sure that the code that someone is committing is indeed the code that needs to go in. It requires some kind of a review to make sure that, okay, it is not breaking, because only a certain people within the team knows that why certain decisions are made in that way. So in those kind of situations, the pull request model that what GitHub made popularized, it still makes sense. But in a team where you know the teams very well, you talk to them on a consistent basis, you need that kind of a control. It's better that give that autonomy to the team to commit to the master itself, rather than going through a pull model, pull request model way. So just thought I'll just bring it in, because I'm not saying, in my opinion, it still makes sense, a lot of sense in the open source world. The pull request model where you have branches and then someone manually merging it and then saying that, okay, it is ready for merging. And what happens when you actually do it? So I'm going to share some of my experiences with continuous delivery. So we were working with a media company in US. What they do is that they deliver informative content within the clinics. So what they usually what happens, so this is Mary. She is visiting a clinic. She has an appointment with the doctor. So usually what happens is you wait at the reception until the time comes. You don't have much to do, right? And you will be thinking about, okay, what is the doctor going to say? And so what this company had an idea, why don't we install Android tablets which airs informative content about certain diseases, about the patients who got cured with that disease, so that they get more connectedness to other patients, and they also become very confident. Okay, mine is not as much problem; it still can be cured. And they started doing that, and we were building that application for them, which it's like a chaos mode application. It just sits there and plays it. It's an interactive thing, because being a tablet, they can take it in their hand and then watch it again, share it with their email or share it with someone else. And they also extended, once they start seeing results with Android tablet, they extended it to the big TVs that you see on the reception area. It cannot be interactive in that case, but the advantage is that multiple people can watch at the same time. So rather than just showing some news, which may or may not be interesting for others, this is more contextual to the patient. And we did it in a continuous delivery manner, because it has a lot of parts. One is that you need a complete setup to control these devices remotely. There are no technicians available at the clinics. You have to make sure that the tablets run all the time. And it was a critical part for their business model. And we started in a lean way, that it started with one clinic, watched how users are using it, watched what is the feedback the doctors have. And one of the very surprising feedback that pleasantly surprising feedback that we got from the doctors is that it improved the quality of the interaction between the patient and the doctor. Because when they watch this, they become more curious about the disease and ask a lot of good questions to the doctor about that, rather than being very, very concerned oh, I'm facing this and stuff like that. So that was not something that we expected to happen, and we did it in that in a continuous delivery manner, release certain things and then see how it works, and then increased it over a period of time. So you can see that spike in the number of devices in the field. Within 2 years, we were able to reach more than 5,000 devices, and we are also able to implement the similar implementation for Linux media players. And they're still running. They have we are not working with them anymore, but they have been very active in this model. So we really saw some values by doing this way. I think I'm going to skip this particular story because I'm running out of time. And if you're really keen about, so the point I'm trying to say is that it starts with the right implementation of continuous integration. That is where we started. We just had, the focus was how do you create a pipeline? How do you smooth the process of commit to delivery, commit to deployment? That was the only thing that we focused. If you want to really listen to how it impacted, I would say that you listen to this talk from this is Tabrato Pal from Capital One. Capital One is one of the major top 10 banks in US. Okay, and they are known for their innovation in their services. And what happened was, in this talk, he talks about how they saw 20x increase in their deployments just by following mainline. They were doing a lot of other automation, but just by moving to a mainline development, which was not easy at a bank where you have a lot of complaints and other things, and it's a legacy system because banks usually will have old systems that they are maintaining, but they saw 20x improvement in number of deployments just by following it without having a lot of impact in their incident reporting. It didn't have equal number of increase in the incidents being reported. And so this is a highly recommended if you really want to see how it impacts. This is one talk where I can talk about that. Just to summarize, start with the premise that okay, when someone says something is done, it is ready for deployment. You cannot have another stage to make sure that okay, it is ready for deployment, and then all else of okay, merging it, testing it again, and stuff like that. Something is done, it can be deployed. That has to be the where you should be reaching. And for teams to do that, always work in small batches. You cannot have big bang releases. It has to be small chunks that you are continually releasing. And continuous delivery helps you to achieve that. And build a lot of safety net to give you feedback. Okay, things are still fine. So this is a interesting picture. This is a safety net, literal safety net that they built while they were building Golden Bridge in US. Okay, and they invested the similar budget for the safety net also, which is very, very unusual. And they saw the results. That is, they had hardly very few incidents, accidents actually. The software that we are building is nothing compared to this kind of a complexity. We are not playing with humans' lives, but and they also were able to complete the work earlier because the workers had psychological safety. They knew that okay, something is there in case something goes wrong. And that improves. Psychological safety is a key for improving your performance. And then they did that, and this is the result. So do that in our software development also. Create a lot of safety net so that you are confident to release. And this is what you get when you have such an environment. People are happy. They are happy. That is what we all want to be. We want to be happy, right? So. And that's it. I don't have anything else. I think we have few minutes for questions.
We've got 6, but I want to applaud you first.
Okay.